Dear students, welcome to the MOOC course on solid and hazardous waste management. Today in this module, we will be discussing about landfill bioreactors. In our previous module, we discussed about what is a landfill or a control method of dumping. Then we discussed about what are the types of landfills, its structure and components. Now, landfills are an engineered structure which are designed to contain the waste and protect them from various environmental and health hazards. Then landfill are considered as one of the largest route of disposal of solid waste. They contain three major components like your liner system, then waste emplacement and the landfill cover. The liner system is generally consists of a natural or a synthetic material which is lined at the bottom and at the sides to avoid or prevent the contact of waste from the environmental matrices like your soil and water. Then comes your waste emplacement where the waste is deposited or loaded in a systematic manner. There we have discussed about three different types of waste emplacement like your layer method, area method and cell method. Cell method is one of the popularly used method in the developing countries. Now, the third or the final layer is the landfill cover. Now, landfill cover protects your waste from the entry of water and from animals which stray into these waste pile and create a chaos. Now, with this introduction, now let us look into the learning objectives of this module. The learning objectives of this module include, first we will discuss about the concept of landfill bioreactor, what are its components, then we will discuss about the different types of landfill bioreactor, then we will discuss about the various factors that influence degradation in landfill bioreactor. Finally, we will understand or discuss about the various advantages, disadvantages and the monitoring parameters that are required for a landfill bioreactor. Now, as I told you earlier, landfill is an engineered structure where the waste is safely disposed and contained to avoid environmental and health effects. They are usually made of cells in which the discrete volume of waste is kept isolated from adjacent cells by a suitable barrier. Now, this barrier can be a liner. Now, it consists of three components: liner system which is laid at the bottom and at the sides and it is protecting or the waste is kept away from the soil and groundwater. The waste emplacement, again as I told you earlier, it is a pattern by which the waste is loaded onto a landfill. Finally, the landfill cover protects the waste from the entry of water and other animals into the waste pile. Now, this figure shows how a landfill actually looks like. Now, why landfill bioreactor, or what is a landfill bioreactor and why do you need a landfill bioreactor? The landfills, as I told you earlier, they are designed with the purpose of safe disposal and protecting the environment. Though it is designed with this purpose, sometimes the leachate and the gas collection system fail and they cause a lot of environmental hazards and other problems. So, to avoid, and also the waste within the landfill takes a long time for its degradation. Moreover, the gas generation is also very slow. Thus, the concept of landfill bioreactors were developed with the purpose of, one, to accelerate or fasten up the rate of degradation, two, the environmental protection. Now, landfill bioreactors are again an engineered structure that are developed with a purpose to speed up the process of waste degradation and to promote environmental protection through proper gas and leachate management systems. Here within a landfill bioreactor, the waste gets stabilized much faster within 5 to 10 years of loading. Now, a minimum of 35 to 40% moisture is required for the waste to undergo degradation at a faster rate within 5 to 10 years. For that, the moisture level are generally maintained by recirculating leachate. Now, leachate, when you recirculate, they ensure that the moisture level within the waste is maintained. Now, if the leachate is not sufficient enough, then you can use water, storm water runoff or wastewater treatment sludges. Now, the efficiency of a landfill bioreactor is increased by certain factors. For example, when you add the waste or the waste that is being loaded, if it is shredded into uniform size, that will accelerate the rate of degradation. So, shredding of incoming waste is one factor. The other one is nutrient addition. Sometimes the rate of degradation is limited due to the absence of certain nutrients like nitrogen. So, you can supplement it with certain nutrients and then the waste degradation can be fastened up. Then pH adjustment will also help in fastening up your waste degradation. Waste predisposal and post-disposal conditioning and temperature control also facilitates faster degradation within your landfill bioreactor. Now, landfill bioreactors are of 4 types and they are classified based on their working mechanism into as aerobic landfill bioreactor, anaerobic landfill bioreactor, hybrid landfill bioreactor and a facultative landfill bioreactor. Now, we will discuss in detail about each one of these landfill bioreactors. Now, aerobic landfill bioreactor is a landfill bioreactor where the waste undergoes aerobic degradation. The air is supplied into the system through a number of vertical and horizontal tubes which are set within the landfill bioreactor. Now, the leachate that is generated during the decomposition of waste is generally recirculated, and in case where the leachate is not sufficient enough, then you can replace it with other liquids like water, other wastewater or stormwater runoff or sludge, etc. Now, this will generally maintain the moisture level, and when you maintain the moisture level, the degradation efficiency will be more. One, second, the microbial inoculum will be added, and third, it will stabilize the waste. Now, these are the main advantages of recirculating the leachate back into the landfill bioreactor. Sometimes air also enters through the leachate. Now, this again will accelerate the rate of degradation in an aerobic landfill bioreactor. Now, this figure, if you see, the waste are loaded in a systematic manner, and you can see on the left side, you can see air is being injected and circulated throughout the entire waste pile, and on the left side you can see a liquid storage tank, and from there the liquid or the leachate is circulated throughout the waste pile. Now, anaerobic landfill bioreactor is another type of landfill bioreactor where the waste is subjected to anaerobic degradation. Here, during the process of anaerobic degradation, you have the gas generation like methane, carbon dioxide, which are generally termed as landfill gases, in short abbreviated as LFG. In an anaerobic bioreactor, the gases are recovered and converted into energy. Now, when you convert it into energy, the greenhouse gas emissions are also minimized. The leachate that is generated from an anaerobic landfill bioreactor is very less, and recirculation is little limited. So, what you can do is you can substitute other or use other water or stormwater runoff or wastewater and ensure that the moisture percentage is maintained between 35 to 40%. Now, when the moisture is appropriate, one, it will increase the efficiency of waste degradation, also it will densify your waste. The gas generation will also be increased when the moisture percentage is properly maintained. Now, the gas generation, if you see in a landfill bioreactor, is twice that of a normal landfill. The rate of gas production is very fast, and the anaerobic landfill bioreactors can generally handle peak waste flows because the gas production is very high in a short period of time. Now, the third type is your hybrid landfill bioreactor. This type is designed to combine the advantages of an aerobic and an anaerobic landfill bioreactor. Here, the simplicity of an anaerobic process and the efficiency of an aerobic process are both combined to obtain a hybrid landfill bioreactor. It is also known as aerobic anaerobic bioreactor landfills. The hybrid landfill bioreactor are designed in a way like the upper portion will be working under aerobic condition, where you will have a lot of pipes through which air is injected into the waste, and the bottom layer will be working under anaerobic condition, where you will not have any pipes for fluxing in air into the waste. Now, the purpose is generally, as I told you earlier, faster degradation, and the gas generation can be recovered and used as a form of energy. Now, faster degradation will also reduce the production of organic acids, and also it will favor faster onset of methanogenic phase. Now, this image shows a hybrid landfill bioreactor. Here you can see the landfill bioreactor working under as two layers. On the top it is the aerobic layer, and at the bottom you have the anaerobic layer. So, gas injection wells are located in the upper portion, and the liquid storage for the leachate circulation, it is laid throughout the landfill bioreactor for leachate circulation. The fourth type of landfill bioreactor is your facultative landfill bioreactor, which are developed with a specific purpose. Here it is developed to control high level of ammonia that is generated during the degradation of waste. Now, high ammonia concentration that develops during the leachate circulation are removed and then subjected to biological nitrification process. The nitrified effluent will again be introduced into the anaerobic landfill bioreactor. Now, under this condition, the facultative anaerobes will use nitrate as oxygen source, and they will finally reduce the nitrates into molecular nitrogen. Now, as you all know, molecular nitrogen is safe and they will not cause any harm to the environment. Like other bioreactors, here also moisture maintenance is very important to achieve better degradation. Now, this is an image of your facultative landfill bioreactor. You can see on the right side you have a unit where the leachate is collected and nitrified, and the nitrified effluent is further recirculated into the anaerobic bioreactor, and here it will be converted into N2 gas. Now, let us discuss about the various components of a landfill bioreactor. Now, just like your landfill, it consists of a liner system, a leachate collection system, gas collection system, and daily and final cover at the top of the landfill, and finally you have environmental monitoring and closure and post closure monitoring systems. Now, let us discuss about each of these components in detail. Now, the liner system, they are generally laid at the bottom and the sides of a landfill. Now, they can be made of natural or synthetic polymers, and they are generally used to protect the soil and groundwater which is lying below. Now, the liners should be strong, impermeable in nature, flexible, they should have a very high tensile strength, they should be tolerant to temperature fluctuation and should be UV resistant. Also, they should be easy to install, economical, and they should be resistant to scratch and chemical degradation, because leachate contains lot of harmful chemicals which can rupture the liner material. Geomembranes, geosynthetic clay liners, geotextiles, geonets, geocomposites, geogrids are some of the liner materials, the synthetic liner materials which are popularly used, and the natural liners, if you see, clay, bentonite enhanced clay, these are some of the examples. The second component is the leachate collection system. The leachate drainage system is used to collect and transport the leachate. Now, they are generally designed in a way to collect the maximum amount of leachate, and the pipes of this drainage system are generally located at the bottom. They can be flexible or rigid, but the joints of these pipes should be flexible so that it can hold the weight or pressure that is created by the overlying waste. The size of these pipes should be larger than the conventional landfill, because the amount of leachate generation will be high. Also, they will avoid clogging due to deposition of the suspended material. The collection pipe network generally drains, collects and transport the leachate through the drainage layer to a collection sump, where they will be taken out for further treatment or disposal. Now, after recirculation, the excess water should be generally removed from the bioreactor to maintain 30 centimeter or more hydraulic head. If not, what will happen is the leachate will leak out of the system. There are generally 5 types of leachate distribution system which is summarized in this table. First type is pre-wetting of waste. Just to wet the waste, you can fit the fire hose to a water tanker and you can do a manual spraying. It is generally a labor intensive process. The second type is leachate spraying, where you use sprinklers. And the third one is surface ponds. This consists of a surface infiltration pond which is fitted above the solid base. Now, these ponds generally collect even storm water and can be used as a water source. The fourth one are vertical injection wells, where the leachate is distributed by pumping or gravity force, and this is one of the popularly used method. And the fifth type is horizontal subsurface introduction. Again, the leachate is pumped or sent through by gravity force. Now, there are a lot of factors that influence the leachate distribution system. They are like you have environmental factors, climatic factors, worker exposure, evaporation loss, reliability, uniformity, and aesthetics are some of them. The next component is your gas collection system. An ideal gas collection system generally consists of a sequence of gas collection wells which are generally located or positioned throughout the landfill bioreactor. They are generally designed based on the volume and density of waste, depth and the area of landfill. The wells are designed in a way that will facilitate easy passage of gas. The gas collection system is one of the important component in a landfill bioreactor, because the gas generation occurs in the early phase and also more amount of gas is being generated throughout the process. Now, the next component is your daily and final cover. Now, here similar to a landfill process, after you load the waste, it should be covered with a cover material, or after every day loading also you should cover it with a cover material. Now, cover generally protects the entry of water into the waste during rainfall or any other form of precipitation. The cover layer is composed, also they keep animals away from the waste material. Generally the cover layer is composed of synthetic and natural materials, and this cover layer extends to a level of 150 mm of soil which is placed over each layer of waste and at the end also. Now, the cover generally prevents the leachate from escaping through the sides of the landfill, and it henceforth provides a lot of safety against certain diseases, vectors, fire, blowing litters, scavenging, and it protects the environment also. Now, the agricultural waste, sludge, worn out geotextiles and compost can be some of the alternative, can act as alternate covers. Now, when you add these material like agricultural residue or compost, they also get degraded along with the waste material. Now, other components which are important are like surface water drainage system. Now, these systems are generally established to avoid water accumulation on the surface of landfill, and it will also serve as a channel to collect the surface runoff during any form of precipitation. Now, environmental monitoring, you have to continuously do it so that you can assess the leachate, you can assess its characteristics, and it will also help in assessing your gas leakage. Now, closure and post closure monitoring, again it is required to see if there is any leakage of leachate or gas from the landfill bioreactors. Now, let us discuss about the waste degradation in the landfill bioreactor. Again, just like your landfills, the waste degradation within the landfill bioreactor undergoes a lot of physical, chemical and biological changes. Now, due to this, the waste gets compacted and the volume of waste also gets reduced. Mainly, it is a biological process which plays an important role and converts the waste into the gases. Now, the different stages that occurs in waste degradation is your hydrolysis or aerobic degradation, hydrolysis and fermentation. Stage 3 is acetogenesis followed by methanogenesis, and the last stage is your oxidation. Now, you can see different types of bacteria are involved in different phases. Stage 1 and stage 5, oxygen plays a major role in degradation. Initially, when the waste is loaded, it will contain a lot of oxygen, and hence aerobic degradation takes place and results in the production of carbon dioxide and water. Further, from the stage 2 to stage 4, it is the anaerobic degradation that takes place, and here the organic acids are produced, and from organic acids are further consumed and converted into acetic acids, and this acetic acid is further converted into methane and carbon dioxide in the methanogenic phase by methanogenic bacteria. Once this is formed, finally once again oxygen enters into the system, and then undergoes aerobic degradation and converts into carbon dioxide. Now, this table summarizes what are the conditions or the optimum conditions that is required for better waste degradation within a landfill bioreactor. If you see, as I told you earlier, moisture is one important parameter which has to be maintained to have a better degradation of waste within a landfill bioreactor. 60% moisture is essential. Oxygen should oxygen is again important, especially the redox potential for methanogens will be in the range of -100 to -300 millivolt. pH should be in the range of 6 to 8. Alkalinity for methanogenesis is 2000 milligram per liter, and temperature should be around 40 degrees Celsius. Nutrients, adequate level of nutrients are required. Sulfate, if it is present, it will decrease the methanogenic activity. So, it acts like a inhibitor. Apart from sulfate, there are also other inhibitors which affect the waste degradation within the landfill. It is ammonia, sodium, potassium, calcium, magnesium and other heavy metals which generally inhibit the rate of waste degradation within a landfill bioreactor. Now, this image shows the gas generation in the different stages of waste degradation within a landfill bioreactor. Here you can see oxygen is present only in the stage 1 and stage 5. In stage 1 it decreases and comes to 0, and in stage 5 it again increases. Now, nitrogen as such, if you see, it is high in stage 1 and slowly drastically it reduces and then comes down or becomes 0 in state at the end of stage 3. Likewise, the carbon dioxide level increases in the middle of stage 1 and peaks out at the end of stage 2, and after that it gradually reduces, remains stable till stage 4, and at the end of stage 5 it becomes 0. You also have hydrogen production which starts at the end of stage 1, peaks at the end of stage 2, and at the end of stage 3 it becomes 0. Now, let us discuss about the various monitoring parameters that influence waste degradation within the landfill bioreactor. Now, continuous monitoring of a landfill bioreactor is essential so that it will minimize the operational failures and it will improve the performance of the process. Now, first, leachate flux. The rate of leachate generation and recirculation should be continuously monitored, because as I told you earlier, the moisture levels will influence your waste biodegradation to a greater level. The moisture level within the landfill bioreactor should be regularly monitored, and accordingly the leachate should be recirculated. Next parameter is your temperature. Now, temperature again should be continuously monitored. This will indicate the stage of biological activity within your landfill bioreactor. Now, in an aerobic landfill bioreactor, monitoring temperature will help us to prevent or avoid fire. Then the next parameter is your moisture. Now, moisture will influence your rate of degradation. Here it will give an idea like how much leachate has to be recirculated within the system. Next is your cellulose and lignin level. Now, when you measure this cellulose and lignin level within the landfill bioreactor, it will help you in determining the phase of biological activity that is actually occurring in the system, and also it will help in determining the rate of degradation. Leachate yield and quality is another parameter which you have to continuously monitor, because leachate is one which you are going to collect and recirculate it continuously into the system to maintain the moisture level. So, also it will determine the rate of degradation and the saturation level of the waste. Now, the characteristic of leachate again should be monitored to find out the phase of biological activity that is occurring inside the bioreactor. Now, waste density and settlement will help you determine how much degradation has occurred, and if you actually know the settlement, you can also calculate how much more waste you can add into the system. The other parameter is the gas flow and quality. Again, when you analyze the gas, you can identify the stage of biological activity within the reactor. Also, the progress in the rate of degradation can also be identified. Further, this will also help in the planning of expansion activity. Now, let us discuss about the various advantages of a landfill bioreactor. The advantages of a landfill bioreactor are the rate of degradation is much faster when you compare it to a normal landfill. Also, since the rate of degradation is fast, there will be a rapid settlement and stabilization that will occur within the system. Then it will reduce the impact on ground and surface water by reducing the contamination. Now, landfill bioreactor will generate high quantity of gas within a short period of time. This is again an added advantage. Also, when more amount of gas is generated and when you recover it for other energy purpose, the greenhouse gas emissions will be reduced. When leachate is being recirculated, it will minimize the cost of leachate treatment. Also, when you recirculate, it will avoid the entry of other pollutants into the environment during leachate discharge. Now, the residue left after degradation in landfill bioreactor does not need any further landfilling because the degradation would have occurred completely. Now, in a landfill bioreactor, inert materials can be periodically removed through landfill mining, and this can again improve the space availability in your landfill bioreactor so that more waste can be loaded. Now, after the closure of a landfill bioreactor, the land can be reused for other purpose also. Now, faster waste degradation in the landfill will also avoid the requirement of a large area of land, thereby the overall cost of landfilling process will be brought down. Now, long term environmental risks are generally avoided with minimum leachate migration and recovery of landfill gas. Now, the disadvantages of the landfill bioreactor is: 1. The cost of construction is high, and as it involves a lot of engineering aspects. Numerous networks of pipes are required, gas collection units are required, which will further increase the cost of construction. You need skilled laborers to operate this landfill bioreactor. You need proper temperature control, especially in your aerobic bioreactors. Now, some of the other drawbacks can be the geotechnical stability, liner chemical compatibility, odor control, availability of other liquids like storm water, sewage and other non-hazardous liquid for recirculation is little difficult. To summarize, at the end of this module, we have discussed about the concept of landfill bioreactor. Now, what are its components, how it is different from a landfill. Then we discussed about the different types of landfill bioreactor like your aerobic landfill bioreactor, anaerobic landfill bioreactor, hybrid landfill bioreactor and facultative landfill bioreactor, what are its significance and how each one of them is different from the other. Then we discussed about how the waste gets degraded within the landfill bioreactor. Then we also discussed like what are the different monitoring parameters which you have to continuously monitor to assess the performance of a landfill bioreactor or to improve the degradation. Lastly, we discussed about the advantages and the various drawbacks that are associated with a landfill bioreactor. I hope you would have enjoyed this module. Thank you.